In this video, we are going to go over specific heat. When heat is added or removed from a substance at its melting or boiling point, a phase change occurs. When heat is transferred at any other temperature, it is transferred to or from the atoms or molecules in the form of kinetic energy as measured by an increase or decrease in temperature. The change in temperature, also known as delta T, that occurs depends on the amount of heat added or removed from the substance, and the unit for that is calories, the mass of the substance in grams, and the specific heat of the substance. Specific heat of a substance is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. The units of specific heat are calories per gram degrees Celsius. And on the right-hand side, you can see that a table of specific heat capacity or specific heats of different substances. Water, you can see, has a different specific heat for each phase it's in. So there's liquid water has a specific heat of 1. Gas water has specific heat of 0.497, and solid water has a specific heat of 0.490. So specific heat is specific to each element and compound. The equation to determine the heat or the amount of energy added or removed is equal to the specific heat times the mass or the amount of sample times the change in temperature, which can be in Celsius or Kelvin. Well, it should be in Celsius. So if you have Kelvin, you need to convert it to Celsius. Substances with a higher specific heat require more heat to be added or removed to achieve the same temperature change as a substance with a lower specific heat. So when you walk on the beach on a hot day, the sand feels much hotter than the water. This is because the same heat energy from the sun causes a smaller increase in the water temperature than in the temperature of the sand, because sand has a lower specific heat, it's 0.16 calories per gram degree Celsius, than water, which is 1 calorie per gram degree Celsius. This is also the high specific heat of water also allows our body to maintain a relatively constant temperature despite temperature changes in the air around us. So calculating the amount of energy required. To calculate the amount of energy required to raise or lower the temperature of a substance from one temperature or another, you need to first determine if a phase change occurred. Heat of vaporization is used to calculate heat that must be added or removed for vaporization or condensation. Heat of fusion is used to calculate the heat that must be added or removed for melting or freezing. The specific heat is used for whenever you're heating just that one phase. So if you're heating your solid up until the melting point. And then all these values are then added to the heats calculated from the specific heat equation for the temperature changes. So to practice, we want to calculate the heat required to raise 45 grams of liquid water from 23 degrees Celsius to 32 degrees Celsius. And the specific heat of liquid water is 1 calorie per gram degree Celsius. We know that the freezing point or the melting point of water is 0 and the boiling point is 100 degrees Celsius. 23 and 32 are between those, so we know no phase changes occurred. So we can use our equation of heat is equal to mass times the specific heat times delta T. And delta T, the change in temperature, is equal to the final temperature minus the initial temperature. So heat is equal to the mass, which is 45.0 grams. The specific heat is 1.0 calories per gram degree Celsius. And the change in temperature is we went from 23 degrees Celsius to 32 degrees Celsius. So our final temperature where we ended up is 32 degrees Celsius. And where we started, our initial temperature is 23 degrees Celsius. We're going to multiply everything together, and our heat turns out to be 405 calories. So that's the amount of energy required to raise 45 grams of liquid water 9 degrees Celsius. So specific heat is the amount of heat required to raise the temperature 1 gram of the substance by 1 degree Celsius. The heat equation is used to calculate the amount of heat transferred to or from a substance not during a phase change.